Hey everybody, it is time for some chapter 3. Let's just jump into it. Let's do this. Where'd it go? Chapter 3, where'd it go? Okay, here we are. Stat 201. Chapter 3 homework. MyPearson. Question 1. Okay. So this first one right here is a contingency table. We have two questions being asked. Question 1, how does someone rate college education? And question 2, which group do they identify with? Are they a U.S. adult or are they a president? So when you look at this right here, it's basically asking some similar questions about how do we read this table. It says, what % of college presidents think that higher education is a poor value? That'd be a weird view to have if you're a college president. Why do you think that? That's a weird view to have. So it says of the college presidents, so we have to go within here and go here. And it says at the start how many college presidents there are, but it'd be 29 out of the grand total. So whatever the total is, we just divide 29 by that, and that'll give it, we're going to do it as a percentage. So there are 1040 college presidents, so 29 out of 1040. So like 2.6% or so, 2.8. So we should do 2.8%. Check answer. There we go. What % of U.S. adults think the value provided is either good or excellent? And so we need to, and it says, what is the comparable percentage of college presidents? It doesn't ask that yet, but good or excellent. And we need to say of the U.S. adults. So we're going to go right here. And this is a conditional distribution of the U.S. adults, which college presidents are kind of a part of, but I guess not for this. Good or excellent, we'd add these two together to get 860. And we divide that by the amount, 2162. And that's going to be about 40-ish percent, 40-ish, just a guesstimate. I love guesstimating things because then if you're way off, you either do the math wrong in your head or on the calculator. And it was about 40%. So 39.8. 39.8. There we go. And then for the college presidents, we're going to do the same thing. So I wish I could just move this down right here. We can just erase it and move it down. But we need to change the numerator and the denominator. And we can't move it down. We'll go to college presidents, and we'll go good and excellent. A little harder math to do, but we can still do it. So that's 7. You're going to add these two numbers together. 788. Double check with your calculator, and 1040. So that's going to be about 780 or 778. Very close to 78. So 788 divided by 1040, going to be about 78%. Ooh, I was way off. The numbers look right. So further off than I would have thought. It's 75.8. 75.8. So let's go right here and do 75.8. There you go. And there's huge differences right here. If you look at these differences, they're vast. And what do we mean by that? Well, given someone is a U.S. adult, the percent who think it's a good or excellent value is very low, low, 40%. And if someone's a college president, it's much higher, 76%. So on average, college presidents have a better opinion right there. So I would say that shows some sort of association. Is it reasonable to conclude that about 5.27% think it's excellent value? And that's 114 out of the U.S. adults. So we can check this math and do 114 out of the 261.2. And it is about 5.27. There's the number by doing 114 out of the total. And while this is a guesstimate, remember we have a sample right here, so this is a reasonable estimate of what the truth might be. We don't know what the truth is, but this is a sample, so we'd guesstimate that's about the truth. The sample is representative, probably is. So the 5.27 is significantly different, no. The sample is likely representative of the U.S. population of adults, so the true value may be close to, but not exactly this. And that's a pretty good statement. I'll pause right there on that. Pretty good statement that the truth is probably close to, maybe not exactly this, because this is a sample to estimate the truth. And that's got the first question. Okay, this one is where people get stuck and they say, how in the world do I do this? Question number 2. So this one is the conditional distribution of a college president. And you're going to do the same thing, but you're going to divide by the total. So there's 1059. And you're just going to divide each number, 36 divided by 1059, and then times 100. and then delete down to the decimals. So delete to 1 decimal, make sure to round. And the same process of 218, because this is out of only college presidents, out of 1059, and then times by 100, and go down to 1 decimal, 20.6. Same process here of take the number 619, and this is only out of college presidents because it's given someone's a college president, and then multiply by 100, and then 58.5 rounds up to. And then excellent right here. This is presidents, right? Hopefully I've been doing the same row the whole time. And then we have 186. 186 divided by 1059, and then we're in times by 100, and it is 17.6. Now, an important thing to note is no one said did not know, not apply, which is going to come into play for the next part of this question. Update failed, that's fine. And you can add up these numbers here because this is about 20. If you notice here, this is, if you add these two numbers, you get actually 21, and it looks like it's probably correct, yeah, because it adds up to 100. Now this one changes the way the data is ordered up here for this table, because what they're going to do is they're going to do something really sneaky. This is where people say, how in the world do I do this? Because it's a trick, kind of. Negative are going to be people who just say poor. So the poor is negative, and then the middle is only fair, and then the positive is going to be the good and excellent. And then we are not going to use this. We're not going to use this. So we're going to remove this. So that means we're going to take 2179 and subtract from it the 71, which is going to equal a total of 2108. And that's because we are removing out these right here. We're removing out those values. So you should have 2108 in your denominator, and you're going to add together these values right here. So every time you do the math right here for these, oh, really? Every time you do the math for those, you're going to divide by 2108. Make sure to take and subtract out. Ooh, look, I already have a math error. Uh-oh. This was a 2, but my handwriting is so bad that I made a mistake. So this should have been a 2 right there, which changes a good bit of the math. Because now we're going to subtract the 71 from that, and we're going to get 5058 over here. Once again, you can use a calculator to make sure you do it right. We might even double check with a calculator. And there we go. So this bottom denominator for all these is going to be 258. It says do not include the values for those. So we're excluding those out of the calculations. And we're going to double check by going 2129 minus 71. And we do get the value right there. So we're just excluding those values, and we're only doing these values within here, dividing by the denominator. So that's got the math. I'm just going to do the math now. If you're wondering what I'm doing, I'm literally taking poor, which is 311, dividing by the new denominator, 2058, timesing by 100. And there's the answer. We're going to round to 1 decimal. And then we're going to take the middle, which is only the 218. And wait, did I grab the wrong numbers? This is US adults. Nope. It is, and I hopefully grabbed 311 for that first one. Let's double check. 311 divided by 2058. Okay, we did that right. The next one's 904 divided by 2058. And there it is right there. It's almost 44% on the dot. It's 43.9. And once again, you could just subtract from 100. It's a reasonable way to do it. So if you're wondering, let's add in the 15.1. We get this right here. And you can kind of see the answer. It's going to be about 41%. So we could just guesstimate. Let's see if we get it right by doing that. And we did get it right. The more traditional way of doing this for the last part right here would be to take the other numbers and add them up. We'll show that right here. Well, I can show it on the screen too while I do it. So here is the numbers that you would add. The 741 plus 102 divided by 2058, and then times by 100, and it rounds to 41%. But with the knowledge that this table should add up to 100%, you can do this. It's probably best to add these numbers and divide by the total minus the extras, less maybe there's a decimal difference that gets you. But that's got this question. Okay. 2 questions down on the homework, and we're just rocking and rolling here. So 4113. A survey of 299 undergraduate students asked them, are you a carnivore, omnivore, or vegetarian? I don't know. Who's a complete carnivore? I know this carnivore diet, but you're telling me you've never had like a potato with your steak? Isn't that omnivore? I mean, potatoes are not meat. Meat of the ground, maybe. I don't know. You never have a salad with your steak. I know some people don't do that, but I just got some like sesame ginger dressing, honey ginger, I think it is. Ooh, it's good stuff. It's good. Little green fibers stuff. Not bad for you. Steak's good. Oh, we were gonna get steaks for Valentine. We should still do that. What's it? Publix has some good sales on steaks. Shout out to Publix. But might make some. Was it when you baste the steak? Take a little rosemary, thyme, butter, and just hot sear. Get that steak dry. Anyways, hungry for a steak. Here's the data. We got here whether someone's a vegetarian and their views on politics, omnivore view on politics, carnivore view on politics. This is a stacked bar chart. A stacked bar chart is the bivariate visualization because you see two categorical variables of of two categorical variables. Bivariate visualization of two categorical variables, and that's what you see. And it does look like there's a relationship. Vegetarians are more likely to be liberal, where carnivores have a higher probability of being conservative, moderate, lesser probability of being liberal. Doesn't mean you are liberal if you are vegetarian. Just means you're more likely, according to this data, according to them. So what do we see right here? And if you look, it'd be vegetarians are more likely to be liberal. That's a huge statement. Vegetarians tend to be more liberal, while those with other dietary preferences and carnivores tend to be more conservative. Yep. The differences are pretty big, and I always like doing this example right here. When the differences are large, you see more gaps between them. What do I mean by that? If we look at the pass rate fail of a test, maybe this is the pass, this is the fail, and this is version A and version B. This is a weak relationship between passing and failing. This is a strong relationship. And as you make them more different, you're changing the conditional distribution, as in, given someone has version B, the fail rate is like 80%. Given someone has version A, the fail rate is like 20%. So conditional means setting one variable to a statement of like, given someone took version B, what's the probability they passed? And the bigger the difference is, the stronger the relationship. So when you see something like this, this would imply a very weak to non-existent relationship, because maybe version B has a slightly higher fail rate. Like given someone took version B, they had a higher fail rate. And I will state this also, you could also see data that looks like this. This would just mean the marginal distribution of test is very different, and the pass rates might be similar. Less people took version A now. Version B has a slightly higher fail rate that could be by random chance. We'll look at things like p-values later on, but the bigger the gap, as in this gap, the stronger the bivariate relationship is, because now given someone took version B, they had a much higher fail rate. So you'd be like, ooh, I don't want to take that version B. So I'd say these gaps are pretty sizable. We'll make it kind of obvious. You can see right here, like where 70% of vegetarians are liberal, only 35% of carnivores are liberal. So I'd say these are large differences. They're real, and they appear to be strongly associated. So nice and easy questions. Nice and easy questions. We like those. Okay. Oh, I deleted my copy paste. I always see like cars outside. I don't have a view of the street. Medical researchers examined 6,272 Swedish men eating those Swedish fish. There you go, eating the Swedish fish. And they found the following mosaic plot. Now, this one's a little bit tricky, but let's think about what we're looking at here first. What do we got? Well, mosaic plots are the visualization of two categorical variables. You have, did they develop prostate cancer? And then how much fish did they eat? So once again, two variables. You ask someone, hey, did you get prostate cancer? Or we look at medical records. And then you say, how much fish did you eat? Large portion of your diet, moderate portion of your diet, you never seldom ate it, or it's a small portion of your diet. And you see most people either have a moderate or small portion. The people who never eat fish or eat it all the time are like not as common. And when you look at this, the prostate cancer at the bottom right here, we can see very few people did get prostate cancer. Well, very few, not a lot, but it's very sad. I think, sadly, Mr. Rogers died of, he died of colon cancer, I believe. Sad times. Great man, Mr. Rogers. And with this right here, I think the first question asks us about this. I think it asks, what percent got prostate cancer? About what percent of all men in this survey were diagnosed with prostate cancer? Now, when you look at this, you're looking at the bottom axis. You're looking at the marginal distribution, which shows you one variable. Remember, the marginal distribution is in the margin. So this is only, it's just showing us more people did not get it. So if you break this up, you could be like, so that would be, how many segments did we make here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's about an 11th. Like one of these segments, you get what I'm getting at, is like this length is about an 11th, which is about 10%ish. It's actually 9.09090909 if you do an 11th. It's a fun number. Ninths are fun too. They're just like playing blah, 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 blah. But I think the numbers here, which is so crazy about this question, is I think you can go as low as 5%. And I'm pretty sure you can go as high as 15%. I think you can. Maybe you can't. Yeah. So I find it to be a fair question. It says 7%. We estimated 9% via our guesstimate, and that's pretty close to 7. I think the bounds are between 5 to 15. I don't think you can go as low as like 3% or something, because that's not 3% of the bar. If you look at this right here, it's apparently 7% by their answer, but 9% I think is a decent enough answer. They want you to see that it's not a lot. It's a smaller percentage than 10ish. And then now we get into some tricky questions here. Are there more men who had cancer and never seldom ate fish, or more men who did not have cancer who never seldom ate fish? Okay. So never seldom, and we're looking at the amount of individuals there are. So this is tricky, and I've covered this a lot of semesters. I want you to think about this. This is bar of gold 1. This is bar of gold 2. The amount of individuals is the area of the bar of gold. What I mean by area is like the total space this takes up. Not the vertical space, not the horizontal space. Think of it as a bar of gold. As in, like, if I were to offer you bar of gold 1 or bar of gold 2, which one would be more gold, as in has more people in it? Think of it as a slice of pizza. Where would you get more pizza? Pizza slice 1, I know it is like a pizza slice like this, or pizza slice 2. Well, in terms of more individuals or bigger size, it's bar of gold 1. There are more individuals over there. Now we'll talk about something different. It'd be those who did not have cancer. There are more individuals. And I think it might ask why. Well, it didn't ask why. One of those questions does. Now it wants to know which is higher, the percentage of men who had cancer who never seldom ate fish, or the percent of men without cancer who never seldom ate fish. Okay. So now it wants to know a higher percentage, and that actually goes within. And this one's very easy to see. It's asking about this. Can I draw it? That. So it's asking which of these is a higher percentage within the group. The one on the left or the one on the right? Like, which of those is wider? And I can barely draw it. Clearly, this is like more percent within the group. So there's a higher percentage for those with cancer who never seldom ate fish. A little tricky, but just understanding that the second one is saying which of these has a higher percentage within the group. There are more never seldom ate fish, like percentage-wise, within yes, than percentage-wise within the no. But total individuals, there's more. And just think about maybe this one, bar of gold 1, bar of gold 2. Obviously, there's more people over here because the size of it is the amount of people. This area is a lot smaller. Like, what's bigger, this group or this group? Clearly, this group has more people in it. Now, which of these has a higher percentage? It'd be number 2 has a higher percentage, as in within those who had cancer, there was a higher percentage of people just barely. And we're talking about this difference right here, that difference between those bars. There's a slightly higher percentage within the yes group of those who identify as a large portion of their diet. The questions are so minutely different. Okay. 23:53. I need more caffeine today. I don't want caffeine. I need caffeine. And when you need caffeine, that's a responsibility that only an adult of my maturity can have. No one gets that reference. Pew Research right here talking about college presidents, asking them, do they think the system's awesome? And we get this mosaic plot. So in this mosaic plot, you are visualizing some of the data from the earlier questions. And we can see right here, presidents have a quite a different view, and it's a pretty big difference right here. This is the one that gets into more specifics on it. So you can look at presidents right here. There were less presidents sampled. It's about a 1/3, 2/3 ratio, as in like 2/3 were adults and 1/3 were presidents by the marginal display in the margin. And also you can see within the presidents, a lot more of them think it's good or excellent, and a lot more here think it's poor or only fair. So now we go back and we see what they ask. First question says, from the mosaic plot, about what percent of the respondents were college presidents? We said about 33%, and we were right. You can find out the exact percentage by finding out how many total individuals there are. Here's the total individuals, or the presidents, plus the individuals there, and I made a mistake. The U.S. adults plus the presidents, and then divide 1055 out of the total, and you get almost 33 to the dot. So it is about 33 on the percentage. From the mosaic plot, is it easier to see if there are more U.S. adults who said college provides an excellent value or more college presidents? So now this is kind of like the last question. It's asking, are there more people in Bar of Gold 1 or Bar of Gold 2? This one's not as clear cut because we're looking at the areas of these. Not do they make up a greater percentage of this group, which that'd be obvious. There's an obvious higher percentage of people who are presidents, that'd be percentage. But the area is the amount of individuals. Like if it asked us to compare this one versus this one, obviously this one takes up more area, which there's more people there. But comparing these two right here, it's a little hard to tell because they're very different sizes for the area, which is the amount of people. So it's not easy to tell. Is it easy to tell? No, because the areas are very different for the two rectangles. Now we're going to ask, is there a higher percentage for the people who are college presidents versus not? And this answer is obvious. We're no longer talking about the area here of group box 1, box 2. It's given someone is a college president, they would be more likely, because there's a higher amount over here, percentage-wise on this bar, close to about 20% if you trace over, maybe about 18%. Comparing that to a little less than 5, like 4.6%. We're going down from 100%. So something like 4.6% of U.S. adults say it's an excellent value. We're guesstimating around 18% of college presidents say it's an excellent value. So a very clear-cut difference between these two in terms of who thinks it's an excellent value or not, and it's more likely to be college presidents saying it's an excellent value. So yes, because the proportions, that should be right. Yep, how much it takes up proportionally. Okay, for the mosaic plot, do you think there's an association? Oh, yeah. Once again, the stronger the association, the bigger the gap is. And this is a huge gap because we can see if someone's a president, they're much more likely to have a favorable view, which makes sense. Yes, because the distribution of the two responses are very different, it appears to have a strong association. Okay. 27, 53. Oh, I lost my copy paste. A survey of 299 undergraduate students asked about their diets and political alignment, and mosaic plot was generated to complete the parts below. Are there more men or women in this survey? We can see this. You notice here that the female bar is a lot smaller than the male bar, and they were also asked, like, you're conservative, moderate, liberal, all this good stuff. Let me see if it might be my... Okay, I'm going to take a quick break in a second here. After this question, we'll take a quick break. There's definitely more males in this survey. Men, because the total, the width's widest bar is labeled M. Total area. Widest bar. No, total area. Just the way they say that. I've done this question a million times. Of course, I'm looking at a call and I'm like, what? It's talking about the total area across. I wish it said like the total widths, not just the widest bar, because there's one group with a lot of men. But it should be the longest bars. There appears to be an association. Let's see right here. There appears to be between politics and gender. Okay, politics and gender. So if you look right here, we've got liberal, moderate, conservative. and the proportion of females gets smaller each time. This is like a 2 to 3, maybe 1 to 4, and 1 to 5. So there's less females as you go towards conservative. So I'd say this is I think they go strong. I hate that they make us choose. I would just say there is one. And because the relative proportion of females in each group tends to become smaller as to become more conservative. There we go. Does there appear to be an association between politics and diet? Oh, gosh, yes. When you look over here, the diet of people who are more conservative is a lot more vegetarian. So, yeah, there appears to be a strong association, policy because the conditional distribution of diet tends towards eating, uh, including meat, more when they become more conservative right there. Yeah, it's really. Does the association between politics and diet seem to differ between men and women? It does. Here at the very end, you see men suddenly, men who are conservative are way more carnivore. So I would say that is something right there. And the difference in the proportion of vegetarians between liberals and conservative is about the same. Because if you look at men and women, vegetarians, proportion of vegetarians between liberals and conservatives, no, is it's larger for men because the vegetarians, men have way less vegetarians. Let's say larger for men. Oh, wait. The difference in proportion of carnivores is where we really see some differences. Larger for men. And we're looking at vegetarians, liberals, and conservatives. Maybe larger for women. This is the way they weird it. I think it's supposed to be about the same. No, larger for women. Yeah. Because women go from like 20% down to 0, and then men go from here. I should have went with my instinct. Just the way they phrase it, like the idea of a little bit larger. So that's just a weird way. I'll be right back. I was like distracted by that. Just the way they phrase it. And it's a trivariate graphic. 3 variables. Be back here in just a second. Bye for now. I just went through, I muted myself when I took a call. I just did the last, Jonan, I just did the last 20, 30 minutes muted. Because I took a call and then I came back and I just did the last. Wow. Well, we have office hours tomorrow. And you know what it literally said to me when I put this into ChatGPT? It says the correct answer is C. And that's what I picked first and said I was wrong. Thank you, Jonan, right there. No, it's all right. It's my fault. I had to take a call. The correct answer is A, as we found out. I mean, at least there's video of it, but like, no, I muted myself. At least I got all the homework done. Here, we'll put muted Brian. Thank you for that right there. Muted. Someone's going to watch the video and be like, what? Stats one muted. The rain, no rain question. See what people can learn from it when I'm totally silent. Oh, thank you so much. I was like, what? I had to take a call real quick. People cutting down trees. Cutting down trees. And then this is obvious because it says make a comparison of males and females. So the answer has to be, like if you look right here, that's like 40, 45, and 10% or something like that. So that's going to be the right answer. And then you can even guesstimate the percentages from this. Like the percent of females in each group is like 42, 46, and then 12. You can find out the exact. And then it looks like males are more conservative. They do not appear to be independent because slightly different in at least one group. And we could check like 42, 45, 12, or this would now be 8 plus 5, 13. And then males are something like 43, 37, 43, 37, 43, 37. The last one had to be 20. Oh, it almost is on the dot. No, we're not going to get this right. We're only going to get the end of it right. We'd have to find out the exact percentages, but you can kind of see it. This one here. It's a very similar solve, but they do not appear. Oh, wait. Yeah, they do not appear to be independent because they're significantly different for at least one group. Well, I'm picking up some pizza for some students tonight. So I thank you, Jonan, right there. I got some big points in the chat. I'm going to go. Well, we're all muted. Introduction. I'm going to go pick up that pizza, bring it back for the students here. Until then, bye for now, everyone. Bye! We've almost got these new intros ready. We're almost there.
This has been going for like 20 hours. This ends now.